using GPS and GIS.
Thanks.
It's the second one.
Good evening, ladies and gentlemen. My work is an effective technique for allocating servers to support cloud using GPS and GIS. As an overview, the cloud, we understand it's give or provide services. These services must be continuous, meaning at any time with high quality. And again, with the cloud related or associated with the marketing. So if we say marketing, meaning we can't delay, and we must go ahead directly with the users. The cloud may be distributed, meaning you have more than one data center over all the world. So maybe these data centers may support each of them, each other. So every time if we have server needed to support, it must be every time we have some server can support that server. The problem really happen when we say that we have the distributed data centers. The problem this problem can happen or see the problem when we need it, or we have server or source server needed to support, and this server can't reach to this support with the same data center. So we needed to support with another location. When we say another location, meaning you needed to technique to see how you can support that server which needed support. In this research, really, I go to get support from outside the data center rapidly and in effective cost. So, if we say this paper, meaning in other words, we needed to reach to some certain server, either relatively and in the same time with the minimum cost. The motivating of research. Really, I go directly to focus about the quality of service, really, in another word. So we go to overcome the shortage in the Q theory, which can get the idle or can compute the idle when search about the server which can support the source server. So we needed to reach a new technique for allocating depending on the relative idle, meaning the Q theory, plus using the GIS and GPS technique to get a minimum cost. Meaning if we say GIS and GPS, meaning you needed to search which one nearest. We say distributed, so maybe some certain server in China needed support from Germany. So maybe it's not correct idea. So we needed, because distributed. So we needed to search which one nearest to avoid the distance, to avoid the problem of network, so we needed to search nearest server to support that server which needed the server. Okay, to satisfy some certain services to overall users under cloud, support another service within cloud when needed that at peak time. Maybe we go to ability to replace the source services in case of failure, backup, etc. The general or proposed idea related with the work, this flowchart can discuss the idea. As we see previously, we must be defined or determine the latitude and longitude of the source servers here, meaning the server which needed support. And in the same time, we needed two techniques here in this work. As we see, steady state queuing model, and again we have hover sign algorithm which can get or navigate the server which can support, meaning the nearest one in another one. So in the final, we go to find overall servers which can support that server which needed the support, and go to make arrangement, as we see here, arrangement meaning which one idle, highest in idle, and get the next, meaning the list of which servers can support that server which needed support. And we go to do hover sign operation to find the distance between each server and the source server, then find which the shortage distance, which one has shortage distance between the source server and the server which can support. So that's the technique which I'm using, or I suggested this type of technique. In the final, we get the server which has rate of idle, and at the same time which has a nearest distance or shortage distance. Steady state queue model, as we know, we needed from this equations we needed to reach to find the busy. Then from busy we can get the idle lambda 0 here, meaning 1 minus busy can get for us the idle rate. Then again we needed another algorithm which I talk about it, hover sign equation, sorry. This algorithm can compute the distance or navigate the distance between each server and the server which needs support. In the final, as experimental result, to implement this idea, we needed a platform, really multi-platform, as we see, Microsoft Visual Studio, C#, Google Map. With Google Map, meaning we needed again Microsoft SQL server, contains the 3 tables, as we see. The first one, allocation. The second one, arrival surface for computing the lambda and the mute. The third one can give it every time when needed the server support, can get it from this table, which can support in this time. And really, we have again a language query for find or search about the rate of idle which can support that. This example may give us idea. That's example for us. As we see, we have more than one data center over the world, and we suppose in China we have some certain server needed support. So which one can give it can support that server which needed support? Really, if we go to queue theory just only. If we go to query theory, queue theory, sorry, we see that's B. Why? Because the idle, as we see in the table here, the idle, high rate idle, you can see B, server B, which in China, within Asia. But with the technique which I go to make implemented, meaning with hover sign equation, we see something different. We go to the second one because we go to get the high rate, relatively high rate of idle plus the nearest or closest to the server which needs support. To avoid the problems of network, to make it a high response, etc. We have more than one idea to make discussion, really. This simple discussion for paper to me previously, using the biocomputing for computing the quality of service and other researcher, really. The proposed system we see it's become more flexible, more effective from view of cost, maybe using GIS and GPS, the others. Using the Google map, others maybe go to use GIS, meaning Geographical Information System, which needed time to make search or navigate, which one better, etc. That's the idea of the conclusions. As we see, the proposed technique for support cloud is more effective cost when it merges between two types or techniques, really. The first one, steady state, Q model, and the second one, our sign algorithm. The flexibility, again, we have more flexibility. Why? Because in the final, we go to make it more than one option, meaning list of idle servers, and go to select which one nearest or close to server which needs support. Again, the proposed technique of allocating may allocate the lowest rate idle. Not really, every time you can allocate it the highest rate idle. Why? Because really over all these computers which are using as servers, supercomputer. And we say supercomputer meaning the difference between them, not like the computers which we use it in another jobs. Really supercomputer meaning in the final we never see a different or a large change between them. The proposed technique again, allocate server shows a high response relatively. Why? Because we'll go to navigate to nearest or close server which attach or nearest to the server which needed the support. And thanks. Maybe I passed very fast. Thank you very much. Any questions, please?
We have about 10 minutes for questions, so.
Excuse me.
Yes.
One of the criteria in your algorithm to select which server should be the first selected.
Yeah.
You measure the distance. Is it a physical distance or you have something else within the distance?
Do you mean about the example?
No, your algorithm.
Really, we go to find the server, meaning which needed to support, and we see which servers can support it.
Yeah.
So that depending on the Google map, of meaning the up to date, you must be up to date maps and location, meaning the location must be gated previously, and we have GPS location must be gated previously, and go to make use it. So meaning physically,
yeah.
Meaning physically.
Meaning physical distance in kilometers, for example.
Depend. It's meaning in the final we go to maxi distance physically.
Yeah.
Yeah.
So the actual distance.
Yeah. There must be.
Now my question.
Yeah.
Sometimes whether your server in USA, for example, or in China.
Yeah.
But normally the distance, the actual distance doesn't mean that you can get good access or fast access.
No. That's meaning.
But that,
Yeah.
that's why I wonder why the actual distance becomes one of your criteria
Yeah.
to select which one to serve the first. The nearest, you said the nearest.
Yeah.
I thought of probably it would be interesting also to measure in terms of the access time to get there.
Yes. Yes.
So from experience, probably you can give priority
Yeah.
a certain location that already been